Hey guys, Copper in Quarter here again. Today I will attempt to process 12 vintage ceramic CPUs and recover their gold content. It is important to note that gold yield estimates stated on many websites are highly exaggerated and should not be relied upon. Let's see how much gold we can recover. These are the 12 CPUs we'll be working with. 1 Cyrix 686, 1 IBM 686, 8 Pentiums, and 2 AMD Durons. Let's jump right into it. The CPUs are broken into small pieces using a hammer and then gently placed into a beaker. I then add distilled water and concentrated nitric acid at about a 1:1 ratio to dissolve the base metals and release the gold foils. After a few hours, the production of nitrogen dioxide gas ceases, and the reaction is complete. I then filter the base metal solution to separate it from the gold-bearing solids. Next, a second distilled water and concentrated nitric acid treatment is performed to dissolve more base metals. Again, I allow the reaction to finish, and I filter the base metal solution. This is the footage of the first filtration process, as I have lost this one. The process is the same. Here, I make a mistake. I cover the solids with hydrochloric acid and add just enough concentrated nitric acid to dissolve the amount of gold that I estimate to be in there. Normally this wouldn't be a problem, but I failed to take into account the amount of base metals left in the solids and the consequences of their presence. As the gold dissolved, it was immediately cemented out of solution by the undissolved base metals because they are more reactive. I then filtered the solution, which I thought was gold-bearing, and performed a Stannous chloride test, and to my surprise, the result was negative for gold in solution. That's when I realized the gold must have cemented out of solution somehow, and as you will see in the next clip, it was in the filter paper as gold powder. This was a rookie mistake, and I should have known better as I'm well aware of the reactivity series of metals and the cementation principle. Nonetheless, I thought it would be important to include it in the video as an example of how things can go wrong and then be remedied. I should have made sure that all the base metals were removed before attempting to dissolve the gold foils, or at the very least made sure all metals were dissolved with a stronger aqua regia solution, which would then need to be denoxed prior to gold precipitation. Having rinsed the CPU pieces into the filter with distilled water and placed them aside, I then removed the remaining base metals with a third distilled water and concentrated nitric acid treatment and filtered this last base metal solution, which is not shown here as I did not record the process. Here, I dissolve the gold powder from the remaining solids with aqua regia. A Stannous chloride test is performed and is positive for gold in solution. Next, I filter the gold-bearing solution. I transfer the gold-bearing solution into a clean beaker. Using sodium metabisulfite, I precipitate the gold out of solution. I make sure all the gold is precipitated out of solution by performing another Stannous chloride test. The test is negative for gold in solution. Here's a time lapse of the gold sedimenting to the bottom of the beaker. After allowing the gold to settle overnight, I performed a series of rinses with distilled water and hydrochloric acid. Now that the gold is thoroughly rinsed, I transfer it to a melt dish. Let's melt the gold into a button. Enjoy the show. The gold button is placed into a boiling dilute sulfuric acid solution to remove any borax residue. The gold button weighs 0.72 grams. We ran into problems during our recovery process, but most importantly, we learned from our mistakes and made it work. We recovered our gold, and it looks beautiful. If you've enjoyed today's video, please like and subscribe. Your support means the world. Thank you for watching, and we'll see you next time.